Good morning, viewers. This is Kasturi Day. Today I'm back with the motion in one dimension chapter. So a few topics are still left, so I'll start with the discussion today. And before I start, I will request you to please do subscribe my channel and continue to stay tuned with me so that you can understand the chapter much better. And please ring the notification bell so that you can uh, get the notification as soon as the new video is uploaded. Okay. And if you're liking the video, press the like button, share with your friends so that they can also benefit from these videos. And don't forget to meditate before you start your day. Okay. And for meditation, let us first start for 1 minute with meditation, and then we will start with the chapter discussion. Okay. So for meditation, let us concentrate on a point of light which is reaching you. Your whole body is lightened up with that point of light. Feel that, and your whole body, your head, your eyes, your nose, your mouth, your tongue, your throat, your hands, your feet, every part, each and every part of your body is getting getting light and also enlightened and energized. Feeling so powerful, so enthusiastic, so happy that whatever you do the rest of the day, you are enjoying that. You're getting interest. It's so interesting. If you do practice it, you get it. So thank you for and so let us start with today's discussion. So we'll start today with acceleration time graph. It's also a type of representation, a determination process of linear motion. Okay, the tool was another tool was first was displacement time graph, then velocity time graph, and this is the okay. In acceleration time graph, the acceleration is dependent variable and is represented by the y-axis, and the time is independent variable and it is represented by. So time will be the x-axis. As yes, time is the x-axis and y is the acceleration axis. And time is independent variable, whereas acceleration is dependent variable. Now the slope of the acceleration time graph is delta a by delta t, that is change in acceleration by change in time. That will give you the slope of the acceleration time graph. Okay. The slope of acceleration time graph is known as jerk, because this is known as jerk. Okay. Delta A by delta t, that is change of acceleration by change of time, that is known as jerk. Okay. And according to the points which are understood from the word, if the slope is 0, then the motion is said to have constant acceleration. Okay. If the slope is 0, slope value is becoming 0, then what happens? The motion of the body is said to have a constant acceleration. It's not changing. Acceleration is not changing as per time. The area under the graph represents the change in velocity. So is the jerk. Okay. The slope of the acceleration time graph is the jerk, and the area which the graph is enclosing, that indicates the change in velocity. Okay. Next, this other type of graphs you can get from the acceleration time graph. Okay, it may be a straight line parallel to the time axis, that is x-axis. It may be a straight line which is passing through the intersection of acceleration and time graph, that is from the zero if it passes, okay, or it may be a parabola. So next is, so there are certain cases which are there in the acceleration time graph. First case, for a stationary body or a body which is moving with uniform acceleration. If the body is moving with uniform acceleration, or if it is a stationary body, that is, it's not moving, then what happens? The acceleration of such a body is zero. Acceleration is zero. There's no change in acceleration. The acceleration is zero. Thus, the acceleration time graph will be a straight line which will be coinciding with the time axis. It will be coinciding with the time axis. So you can see from the picture, first picture, see a blue line which is coinciding with the time axis. Okay, x-axis, the blue line is coinciding with the time axis. So that blue line is the slope of the acceleration time graph. Okay, and this is coinciding with the time axis, indicating that the body may be, it may be stationary object, or the body may be having a uniform acceleration, and the acceleration is, value of acceleration is zero. Okay. Now we come to case 2. Okay. For a body which is moving with uniformly increasing velocity. Okay. Its velocity is increasing but uniformly. Okay. In that case, what happened? The body is said to be moving at constant acceleration. The acceleration is not changing. Here. First case, acceleration is itself a zero because the body is stationary, or if it is moving with uniform acceleration. Okay, then the acceleration becomes, value of acceleration becomes zero. In the second case, what happens? Velocity is the object of the moving body. The motion of the body is uniform. With uniform velocity, and it's increasing. The velocity is increasing but uniformly. In that case, what happens? Acceleration becomes constant. There is acceleration, but it is constant. In that case, the acceleration time graph will be a straight line which will be parallel to the time axis. It will be parallel to the time axis and not coinciding like that of the first case. So in that case, the acceleration time graph, the slope will be parallel to the time axis. Second case completed. Now we move on to third case. Third case, what happens? For a body which is moving with uniformly decreasing velocity. That is, its velocity is decreasing, but it is uniformly decreasing. In that case, the acceleration will be considered as retardation. That is, acceleration will also be changing, uniformly it will be changing, constantly it will be changing, but constant retardation will be there. Okay. So the acceleration time graph will indicate a retardation which will be constant. Okay. That means the acceleration time graph will indicate the acceleration which will be negative, but that will be constant. That is, it will not change. Okay. Retardation, that means it will not. Retardation, that means negative acceleration, and constant means the acceleration will not change. Okay. So negative acceleration, that also will not change. It will be constant. But here, in this case, the velocity will be decreasing velocity, uniformly decreasing velocity. This time, the acceleration time graph will be a straight line which will be parallel to the x-axis, but it will be on the other side of the time axis, not with the positive side, but will be on the negative side, indicating negative acceleration. Okay, that means it is downward. See, you can see from the graph that in the first case it was parallel to the, it was coinciding with the time axis. Second phase, it was parallel to the time axis, but it was in the positive side. From here it was. Now it is negative acceleration, so it will be downside of the time axis, indicating negative velocity and negative acceleration. Okay. Then for a body, fourth case, for a body with non-uniform acceleration. Here, acceleration is non-uniform. That is, the change in acceleration is non-uniform. A body is said to be moving with constant varying velocity. Okay, the velocity is constantly varying, constantly it's changing. Okay, that time the acceleration time graph will be a curve. Okay, that will be a curve. Next, slope of acceleration time graph. The area under any acceleration graph for a certain time interval gives the change in velocity for that time interval. So the area which is enclosed below this slope, below the acceleration time graph, indicates the change in velocity for that time interval. If this is the area we consider, below this graph, then this will indicate the velocity that for that time interval. The slope of acceleration time graph represents a quantity known as jerk. In this slope indicates the jerk. Now, what is jerk? Jerk is the rate of change of acceleration. What is it? It is the rate of change of acceleration. In the given acceleration graph, the slope is equal to rise by run. Okay, the slope is equal to what? Rise by run. What is rise? A2 minus A1. Rise, it is rising, that is A2 minus A1. And the run is T2 minus T1. Okay. Now, the area under the acceleration graph represents the change in velocity I told you. That is, the area under the graph for a certain time interval is equal to change in velocity during that time interval. Okay. Here, next we move on to area under the acceleration time graph. So let's say it is delta V. That is the change in velocity. We know that area indicates the change in velocity. So that will be delta V, that means change in velocity. Now, for example, if the graph shows a constant acceleration of 4 meters per second square, the graph is showing a constant acceleration of 4 meters per second square for a time interval of 9 seconds. Then, therefore, the change in acceleration will be change in velocity by change in time. That means change in velocity is equal to change in acceleration into change in time. That is 4 meters per second square into 9 seconds. That means 36 meters per second. That is the answer for change in velocity. Okay, clear? Now, the area under any acceleration graph for a certain time interval gives a change in velocity. That is, it is indicating that one only. That is 36 meters per second. That is equal to the area of the acceleration time graph for a certain interval of time. Okay, under the graph. Okay. So that will be the change in velocity for that time. Next, we come to the area. This is also area under the acceleration time graph. Now, suppose a race car driver is cruising at a constant velocity of 20 meters per second. His velocity is 20 meters per second. Suppose we just consider it. And as she nears the finish line, the race car driver starts to accelerate. Its velocity was constant. It was 20 meters per second. But when she is going to finish it, so that time what happens? She increases her acceleration, starts to increase her acceleration. Okay. Now the graph gives the acceleration of the race car as it starts to speed up. Okay. If the race car has a velocity of 20 meters per second and time was 0 seconds, so the area under the acceleration time graph, delta V, is equal to half into 8 into 6. Okay. So what happens? 20 meters per second At the time 0 will be time is equal to 0 seconds. Okay, if the race car is there, and in the if it is 8 seconds, and this acceleration, the area under the acceleration time graphs is the change in velocity is equal to half into 8 into 6, that is 24 meter per second. Meter per second, that will be the change in velocity. Okay. Now to calculate the final velocity, it will be change in velocity is equal to final velocity minus initial velocity. So initial velocity was 20 meter per second. We don't know the final velocity. But change in velocity is 24 meter per second. So final velocity is equal to 24 plus 20, that is 44 meter per second. The final velocity. So the final velocity that has increased from 20 meter per second to 44 meter per second. Here, next, the motion under gravity. See, acceleration is also experienced between acceleration is also experienced when there is free fall on the earth. When a body falls freely on the earth, that is due to the acceleration due to gravity. Due to gravity, it experiences body experiences that acceleration. Okay. That is, motion appears due to gravitational force of the earth. Now, when a body falls freely on the earth under the influence of gravity, it is said to be moving with constant acceleration. When it is free falling, an object, when we fall, when we are allowing that object to fall freely from above towards the earth, that means what happens? The acceleration becomes constant. Okay. Now its value, acceleration due to gravity, that value is 9.8 meter per second square, not 2, but it's square, 9.8 meter per second square. Like that, if the body is moving upward against the gravity, like if we throw a ball from down to up, like this, then it is moving with constant retardation. Why? Because it's moving on the opposite direction, opposite from the earth. So that means it's a constant retardation, and that value is also 9.8 meters. Okay. Now the acceleration time graph for a free falling body is as shown in the figure. Excuse me, like this. So free falling, it will be like this. It will be parallel, that is constant acceleration. So it will be parallel to the time axis. At any point of time, there will be acceleration will be constant at 10 meter per second. That is 9.8 meter per second square. Or 10. You can approximately it will become to 10 meter per second square. Okay. So, and the velocity time graph for this body is given by finding the area under the acceleration time graph, that is very different in the. So if we consider a velocity time graph of this type of object, which is falling freely, we can find out by finding the area under the acceleration time graph at different times. Okay. It is because the area increases uniformly after every second. Why can we do this? Because the area increases uniformly after every second. See, 1 second, 2 seconds, 3 seconds, 5 seconds, 5 seconds. Then we will see that the area under this graph, the area will be constantly increasing. Okay, uniformly it's increasing. See here, say it is 10 meter per second square, then it will be 20 meter per second. By 10 it is increasing. So like that. So it will be increasing uniformly for every second. And that will be a straight line which will be inclined to the time axis. A straight line which will be inclined to the time. Next is displacement time graph. For this body is given by finding the area under the velocity time graph. Okay, the displacement time graph, we can find the area which is under the velocity time graph at different intervals. It is so because the area increases non-uniformly. Here, in this case, the area increases non-uniformly, but in acceleration time graph, in the velocity time graph, it would be the area was increasing uniformly. But here it will be non-uniform increase for every second, and therefore it will be a curve. Now, for a free-falling body, drop from rest. From rest, if we drop a free-falling body, the displacement is directly proportional to the square of the time. Okay? So it will be directly proportional to the square of the time. So 1 by 2 into 80 square will be equal to t square. Okay? Directly proportional to t square. So S versus t square will be equal to S means displacement by time square will be a straight line which will be inclined to the time axis. Clear? Next, we are moving to equations of motion. So in this case of uniform acceleration, there are three equations of motion. For uniform acceleration, there are three equations of motion which are also known as laws of constant acceleration. Now, these equations are used to derive the components like displacement, velocity, that is initial and final velocity, time, and acceleration. So there are three equations of motion which are also known as laws of constant accelerations, and these equations are used to find the displacement, the velocity, that is equal to initial or final velocity, time, and acceleration. But they can only be applied where acceleration is constant and the motion is a straight line. So this is the condition where these equations can be put. That is, where the acceleration has to be constant and the motion has to be a straight line. The three equations, what are the three equations? First one is v is equal to u plus at, that is final velocity is equal to initial velocity plus acceleration into time. Then s is equal to half u plus b into t, or ut plus half at square, that is s means distance, or displacement. Displacement is equal to half u plus v, that is u plus v into t, that is ut plus half at square. Okay, and v square is equal to u plus 2as. V square is final velocity square of final velocity, that is equal to initial velocity square of initial velocity plus 2 into acceleration into displacement. Okay. Now these equations are referred to as what? SUVAT, SUVAT. That stands for displacement, initial velocity, final velocity, acceleration, and time. So remember this code word, that is SUVAT, SUVAT. That means displacement, initial velocity, final velocity, acceleration, and time. Okay. Now, how to derive the equations of motion? First equation by graphical method, if we do, we will see that velocity time graph if we consider. Then let's see from the picture, see OD. OD is initial velocity, that is u, and OC is final velocity. Okay, OC, that is final velocity, that's v, and OE is equal to dA, that is time, t, and uniform acceleration is a. From the graph, BE is equal to AB plus AE. Okay, from the graph, BE is equal to AB plus AE, right? Total BE is equal to BA plus AE, right? So for V is equal to, that is final velocity is equal to DC plus OD, that will be equal to QAB is equal to QAB equal to DC, and AE is equal to OD. DC and AE is equal to OD. AE is equal to OD, and DC is equal to not Q, it will be AB, not Q. It will be AB is equal to DC and AE is equal to OD. Okay, so DC plus V. DC plus V. V is OD, sorry, C. This is equal to AB and QOD is equal to U. OD is equal to U. OD is equal to not Q, it's OD. OD is equal to U and AB is equal to BC and AE is equal to OD. So this OD is equal to U and DC is plus V is equal to 1. That will be equal to 1. So DC so that will be equal to, therefore A acceleration is equal to V minus U by T. V minus U by T. Okay, and acceleration, therefore OC minus OD, OC minus OD will be DC. OC minus OD by T, that will be equal to DC by T. Therefore AT is equal to DC. For substituting 2 in 1, for substituting DC 2 in 1 DC, we can write in place of DC, we can write AT plus U. This will be U, not V. This will be U. DC plus U and DC plus U, not V. Okay. So then what will happen? V is equal to AT plus U, or you can say V is equal to U plus AT. Okay. So I think I'll stop here. I'll discuss this equation process in my next video. In clear understanding, I will tell you. Clearly, I will make you understand. Okay. So till then, please go through this. If you have any doubt, please let me know. Write in the comment box. And stay tuned with me. Please to subscribe my channel. And if you're liking the videos, share with your friends. And regarding this chapter, a few equations are still left, so I will discuss them. And then I will start with ICSE pattern questions, and then I will discuss the other back questions with you all. So till then, please to meditate and continue with your these videos, and so that you can understand the chapter much better. And if you have any doubt, please to write in the comment box. Okay, and you can also write in my email ID kasturi74@gmail.com. Okay, thank you for watching and have a good day.